Let's look at Dirac delta function, or also called as unit impulse function. Now, when a large force acts for a very short time, for example, a bat hitting a ball, or a, a, a sharp voltage spike due to shortening. Okay, so basically what happens is it keeps going like this, and suddenly it, you know, jumps. Okay, this type of situations can be handled using Dirac delta function. Now, what is it actually? So the way it is defined is delta t minus a is equal to 1 by epsilon when t is between a and a plus epsilon, and it is 0 when t is anything other than this. So I can write it as otherwise. So here all it is 0, but here it is 1 by epsilon. Now, as you can guess that as epsilon becomes smaller and smaller and smaller, this spike goes higher and higher and higher. Okay, so it tends to infinity as epsilon goes to 0. But uh, the thing is, let me just mention that as epsilon tends to 0, the height of the strip increases in such a way that the area under the curve is always 1. Okay, so therefore we can say delta of t minus a is equal to, so as epsilon becomes smaller and smaller and smaller, this 1 by epsilon becomes larger and larger and larger. So it will tend to infinity when t is equal to a, and it will be 0 when t is not equal to a. And this would happen in such a way such that the integral, that is the area under the curve of this delta function dt, is always equal to 1. Okay, so certain properties we can easily make out. Delta of t minus a is equal to 0 when t is not equal to a, right? That is first. Second one is the integral from a minus epsilon to a plus epsilon, delta of t minus a dt is equal to 1 for epsilon greater than 0. And the third property is integral a minus epsilon to a plus epsilon of f of t, and then delta of t minus a dt is equal to f of. So whenever you encounter this integral, you can immediately say function of a. And here again, epsilon has to be greater than 0. It can't be 0. Now, remember, whenever we want to solve differential equations, we require the Laplace transform, right? So Laplace of this delta function t minus a is going to be equal to, let's actually apply that, 0 to infinity of e to the power of minus st delta of t minus a dt, which is equal to, remember, we can take this as one function times this, a function times this integral, right? So if we take it in this form, then we can directly say it is going to be equal to f of a. So f of a would be equal to e to the power of minus s a, or we can say e to the power of minus as. Laplace transform of this is e to the power of minus as. Now, you might be wondering, how did I convert this a minus epsilon to a plus epsilon to 0 to infinity? Remember, our as per the definition, we are talking of what? We are talking of a to a plus epsilon. So if a is 0, we are talking of 0 to epsilon, right? So here, before 0 and after epsilon, it's all 0. The function returns 0. So whenever t is not equal to a, so if a is 0, if t is not equal to 0, it is 0. So we just have to focus on the positive side, because negative side full is 0. Okay, and within this also, beyond epsilon, that is if a is 0, this we can convert it into 0, because before that it is all 0, the integral is 0, and if a is 0, 0 plus epsilon, as it tends to infinity, it will become infinity. Yes. Okay, so that is the Laplace transform of the delta function. Now, very interesting fact. Interestingly, we can look at Heaviside function, which we saw in the previous session. This is what it is when t is less than a, it is 0, and when t is equal, sorry, not equal, is greater than or equal to a, it is 1. Now let's say we want to differentiate this. So dh by dt is equal to, let's take the limit form. Limit as delta t tends to 0, we will have delta h by delta t, right? So remember, for t less than a or t greater than a, graphically we can see that the derivative is clear, right? Because it's just a straight line, horizontal line. The function is a straight horizontal line. That is, slope is 0, right? So therefore, delta h equal to 0, because there is no change in delta h. So which means that delta h by delta t, as t varies, h doesn't vary. So this will be equal to 0. Now, if we pick 2 points equally spaced on either side of a, say for example, a minus epsilon and a plus epsilon, then delta h is equal to 1, delta t is equal to a. So therefore, dh by dt is equal to limit as a approaches 0 of delta h by delta t becomes limit as a approaches 0. I can actually do the substitutions here itself. It becomes 1 by, actually what I can do is I should, a tends to 0. Now this becomes infinite. Again, graphically it is clear as the graph jumps from 0 to 1 vertically. That is, slope is infinite. So therefore, dh by dt is equal to what? It is 0 when t is less than a. It is infinite when t is equal to a, and 0 again when t is greater than a. Yes. Or what we can do is we can, rearrange this to say it is infinity when t is equal to a and 0 when t is not equal to a. But isn't it the definition of delta? So delta of t is equal to this. So therefore, Dirac delta function can be treated as the derivative of Heaviside function. Okay. So another way of looking at the delta function. Now let's actually solve a problem using this. So let's say we are given a differential equation y double prime plus 2y prime minus 15y is equal to 6 delta t minus 9, and there is initial value. So y of 0 is equal to minus 5 and y prime of 0 is equal to 7. Okay, straightforward. We take the Laplace on both the sides. Laplace of y double prime plus 2 times Laplace of y prime minus 15 of Laplace of y is equal to 6 Laplace of delta t minus 9. Okay, so let's actually do this. First, let's take this. This will give us s square capital Y of s minus s y of 0 minus y prime of 0 plus. Now let's take this 2 times s capital Ys minus y of 0, and now let's take this minus 15 times capital Y of s is equal to 6. Now Laplace of this is what? Just now we looked at, this is e to the power of minus as. So e to the power of minus a is what? 9. So 9s. Okay, so let's take y of s out. S square plus 2s minus 15 minus s times y of 0 is minus 5 minus, now here y prime of 0 is 7, then minus into plus minus 2 times y of 0, which is 2 times minus 5, and this is equal to 6e to the power of minus 9s. Again y of s, this we can factorize s square 3 5, right? So negative here and positive, so this should be positive. This becomes plus 5s, this becomes minus into minus plus 10 minus 7, so plus 3 equal to 6 e to the power of minus 9s. Okay, y of s is equal to, let's take this in a bracket and take it to the other side. So 9s, when we take this to the other side, it becomes minus 5s plus 3, and this goes to the denominator. So s minus 3 times s plus 5. Okay, now remember, we have to convert it into partial fractions, right? So this would become, let's take it one by one. 1 by s plus 5 times s minus 3 is equal to a by s plus 5 plus b by s minus 3. Okay, so this becomes a is equal to as minus 3a plus bs plus 5b. Coefficients, equating the coefficients of s will give us a plus b is equal to, there is no coefficient, There's no s here on this side, so 0. Similarly, of constants, this gives us minus 3a plus 5b is equal to 1. Now let's multiply this by 3. We get 3a plus 3b is equal to 0. Minus 3a plus 5b is equal to 1. This cancels. We get 8b is equal to 1. B is equal to 1 by 8. Okay, let's substitute this in this. A plus b is equal to 0. A plus 1 by 8 is equal to 0. A is equal to minus 1 by a. So our the partial fractions of 1 by s plus 5 times s minus 3 is equal to 1 by 8, just to make sure minus doesn't come in the beginning, s minus 3 minus 1 by 8 s plus 5, that is 1. Here we have taken, this is a constant, so we ignored it and we took it as 1 by s minus 3 times s plus 5. Now we have to take the other part, 5s plus 3. So let's do that. This is 1. Now the second partial fraction, this would be 5s plus 3 by s plus 5 s minus 3 is equal to a by s plus 5 plus b by s minus 3. Okay, so 5s plus 3 is equal to as minus 3a plus bs plus 5b. Again, equating the coefficients, 5s, as, bs. So a plus b is equal to 5. And minus 3a plus 5b, minus 3a plus 5b is equal to 3. Let's multiply this by 3. We get 3a plus 3b is equal to minus plus 50. Minus 3a plus 5b is equal to 3. These two cancel out. We are left with 8b is equal to 18, or b is equal to 18 by 8, 2 nines by 2 fours. Now a plus b is equal to 5. So a plus 9 by 4 is equal to 5. A is equal to 5 minus 9 by 4, which is 5 fours 20, 11 by 4. So our 5s plus 3 by s plus 5 times s minus 3 becomes 11 by 4 times s plus 5 plus 9 by 4 s minus 3. So that is the partial fraction. Okay? So now let us say capital F of s is equal to 1 by 8 s minus 3 minus 1 by 8 s plus 5. Right? Now take the inverse Laplace. So f of t would be 1 by 8 e to the power of 3t minus 1 by 8 e to the power of minus 5t. Similarly, let's take g of s is equal to the other one, 11 by 4 s plus 5 plus 9 by 4 s minus 3. Again, inverse Laplace will give us g of t is equal to 11 by 4 e to the power of minus 5t plus 9 by 4 e to the power of 3t. Okay, now let's go back to this. Where is that? This one, capital Ys. Capital Y of S is equal to, I'll rewrite that statement, 6e to the power of minus 9s minus 5s plus 3. This is s. Why s plus 5 times s minus 3. So now this becomes 6e to the power of minus 9s times, if I take it out, I'm left with 1 on this. So the partial fraction related to that is 1 by 8 times s minus 3 minus 1 by 8 s plus 5 minus this minus and then the partial fraction related to this part. So that will give us 11 by 4 s plus 5 plus 9 by 4 s minus 3. Now let's open up the whole thing. And denominator s plus 5, let's take it together. So we end up with minus 9 by 4 s minus 3. 9 by 4 s minus 3, then plus 3 by 4 s minus 3. Here s minus 3 is 1, so I'm going to end up with 6e to the power of 9s by 8 times s minus 3. 2 3s, 2 4s, so 3 by 4. Then minus 11 by 4 s plus 5 s plus 5 minus 6e to the power of minus 9s by 8 times s plus 5. Again, this would cancel out 2 3s, 2 4s. So I'm left with minus 9 by 4 s minus 3 plus 3 e to the power of minus 9s by 4 times s minus 3 minus 11 by 4 s plus 5 minus 3e to the power of minus 9s by s plus 5 4, right? Now remember, this is capital Y of s. Now let's take the Laplace inverse. This will give us y of t is equal to, this is pretty straightforward, 9 by 4 e to the power of 3t. Okay, similarly, this will also be pretty straightforward, 11 by 4 e to the power of minus 5t. Okay, now let's take the second term, plus 3 by 4 uh, e to the power of 3 times t minus 9. Okay, and then g of t minus 9. This is heavy side function related Laplace transform, and minus 3 by 4 e to the power of minus 5 t minus 9, and then g of t minus 9. So we could take out 3 by 4 common out, we can take 1 by 4 common out, or we can just leave it as it is. So this is the solution for this differential equation. That's it. Bye.